shaping of cognitive abilities. The importance of cognitive skills in explaining socio-economic success is now firmly established. An emerging body of empirical research documents the importance of non-cognitive skills for predicting wages, schooling and participation in risky behaviors. Hegman and Arza demonstrate that cognitive and non-cognitive skills are equally important in explaining a variety of aspects of social and economical life, in the sense that movements from the bottom to the top of the non-cognitive and cognitive distributions have comparable effects of many outcomes. There is a sustainable body of empirical research on the determinants of cognitive test scores and their growth. There is no previous research on the determinants of the evaluation of non-cognitive skills. On the theoretical analysis of Kanha and Hegman Locher and Mostrova, we estimate the joint evaluation of cognitive and non-cognitive skills over the life scale of children. We model the self productivity of skills as well as their dynamic complementary. Our technology formalizes the notion that non-cognitive skills foster acquisition of cognitive skills by making children more adventuresome and open to learning. It also formalizes the notion that cognitive skills can promote the formation of non-cognitive skills. With our estimated technology, it is possible to define and measure critical and sensitive periods in the life cycle of child development and to determine at which ages inputs most affect the evolution of skills. Psychologists who study child development have long advocated the importance of understanding the formation of non-cognitive skills for interrupting the effects of early childhood intervention programs. Zinker and Butterhin, Heeman Sixert and Arza note that the preschool program did not raise IQ but promoted success among its participants in a variety of aspects of social and economic life. Our analysis of non-cognitive skills, their role in shaping cognitive skills, our investigation of the role of non-cognitive skills in shaping cognitive skills, and our determination of the effectiveness of parental inputs on the formation of both types of skill over the life cycle are the first step towards providing a unified treatment of the early intervention and family influence literatures. Coming to the history, Spearman in 1904 first popularized the observation that individuals who do well on one type of mental task also tend to do well on many others. For example, people who are good at recognizing patterns in sequences of abstract drawing are also good at quickly arranging pictures in order to tell a story, telling what three-dimensional shapes drawn in 2 dimensions will look like when rotated, tend to have large vocabularies and good reading comprehension, and are quick at arithmetic. This pattern of moderate to strong positive correlations across the whole spectrum of mental abilities led Spearman to hypothesize the existence of general mental ability similar to be the common notion of intelligence. A person's ability with any particular type of task would be equal to the sum of that person's general ability plus considerations unique to that particular task. Thus, general ability could be measured by constructing subsets of a number of similar items of different complexity. Each subset would present items of a different type and individual scores across subsets could be aggregated. Task specific factors would average out, leaving the final score as mainly a measure of general ability. Or using an approach like this, Binet developed the first IQ test as a way of identifying students academic potential. That test was adapted for use in English by Terman and in 1916 became Stanford Binet IQ test, still one of the most commonly administered tests of cognitive ability. Spearman hypothesis of a single general mental ability and many specific abilities was challenged by Thurston in 1935, who popularized the notion that people had a number of independent primary mental abilities rather than a single general mental ability. Both Spearman and Thurston made contribution to the development of factor analysis as a way to identify the presence of unobserved variables that affect a number of observable variables. Today, the Spearman-Thurston debate has been resolved with a compromise. The most common view among psychometricians who study cognitive ability is that there are a number of different abilities. Some people are better at solving problems verbally, while others are good at solving problems that involve visualization. Some people who are good at both of these things may be only average at tasks that rely heavily on memory. However, there is a tendency for people who perform well in any of these broad areas to perform well in all other areas as well. Most modern tests of cognitive ability provides both a full scale score, that is most reflective of general intelligence, and a number of special ability specific subscores as well. Coming to validity, Alfred Binet is considered the first successful test of cognitive ability in that it was able to accurately predict teachers' assessments of their long-time students on the basis of a relatively short verbally administered test. Scores on tests of the cognitive ability correlate well with common perceptions of how bright or smart someone is. They are also strongly correlated with measures of academic achievement such as achievement test, scores, grades, and ultimate educational attainment. They are less highly correlated with many important life outcomes including reported annual income and job status. Performance on a wide range of jobs and work tasks is positively related to cognitive test scores, with performance on more demanding jobs having higher correlations. Some have claimed that general cognitive ability is responsible for most of this explanatory power. This was a major theme of the controversial bestseller The Bell Curve. Hegman, in a review of that book, argues that even though it has a significant exploratory power, many other factors, both cognitive and non-cognitive, matter as well. Finally, test scores are correlated with a number of social behaviors including unwed motherhood, criminal activity, and welfare receipt. While these correlations are substantial and cognitive test scores are typically better predictors of most of these outcomes than any other single personal attribute, they still explain less than half the variance. Individual scores on tests of cognitive ability also tend to be strongly correlated over time, much more so for adults than for children. A study of older adults found their full scale IQ scores to be correlated 0.92 when tested at 2 points in time 3 years apart. In contrast, a study of children tested at 2 points in time roughly 2 years apart found to be correlations of the only 0.46 for those who were less than 1 year old at first testing and 0.76 for those who were 1 at first testing. It is common to draw a distinction between test of achievement and test of ability. Achievement test measures how much knowledge the test taker has accumulated in a particular area, while ability test endeavour to measure how quickly a person can solve unfamiliar problems. Typically, scores on the two types of test will be highly correlated. In fact, all tests of ability are to some degree tests of achievement, as it is impossible to measure ability without also measuring the test takers' reading or verbal comprehension at least. Further, to the extent that the task being tested relies on the knowledge of geometry, arithmetic, general knowledge, etc., the roles of the academic test and ability test are confounded. Cultural bias has been a concern with knowledge based tests. Some knowledge is more accessible to some people than others. For example, we would expect that a child growing up with upper middle class parents in New York or Paris to find it easier to learn the distance between the two cities, that is, a general knowledge questions that was once on one of the popular IQ tests, than someone from the slums of St. Louis or a tribeman in the bush in Africa. For this reason, a number of tests have been constructed that require minimum amount of prior knowledge, such as Cattell's culture fair test, that is also called as Cattell test, or it is also called as Raven's progressive matrices test. Coming to group differences. No matter what test is administered, men and women of the same background tend to have very similar average scores on tests of cognitive ability, though they differ slightly on their performance on some subsets. However, there are large differences across ethnic groups and geographic areas. The differences that has generated the most controversy is the difference in the average scores of US blacks and whites, which is typically reported to be about 1 white standard deviation, though this gap has declined some in recent years. Do these represent real differences in cognitive ability, or do they reflect culture bias in the test? Defenders of the test offers several pieces of evidence suggesting that they are unbiased. Foremost is the evidence of external validity. The same regression equation that predicts outcomes such as job performance, grades or educational attainment for one group will typically do a similar good job for any other group. Also, different groups find the same questions more or less difficult. Members of different groups with similar scores will have similar patterns of right and wrong answers. If some questions are more culturally biased than others, the disadvantaged group should find those items more difficult than the mainstream group does. But researchers looking for such cultural bias have evidence of it. One of the groups being compared is made up of non-native speakers of the language in which the test was administered, in which the case scores on the questioning requiring a better knowledge of language will be lower. Surprisingly, to the extent there are black-white differences across test items, blacks do worst on what seems to be some of the least culturally dependent items, those involving abstract or symbolic problem solving. Differences tend to be smaller on seemingly culturally rich items such as general knowledge. Hurston and Murray provide a review of the evidences on bias. The best evidence that test can be biased in at least some circumstances come from studies of a phenomenon called stereotype threat. It has been showing that reminding people of their group identity can cause them to perform in ways more consistent with stereotypes of the group abilities. For example, blacks have been found to perform worse on some particularly difficult vocabulary items when asked to answer a questionnaire that asks them to state their race before taking the test, or when the test was represented as a test of intelligence as opposed to a test of vocabulary. Women who were told that the difficult math test they were taking generally showed gender differences performed worse than those taking the same test who were told the test showed no differences. Men showed the opposite effect and performed better when told the tests showed a gender differences. However, it has not been demonstrated that stereotype threat produces sustainable bias on standard test in standard test taking circumstances. While most evidence is consistent with the view that tests provide a fair measure of the underlying concept of cognitive ability across ethnic groups, it is not conclusive. For example, since tests rarely explain as much as half the variance in the outcomes in studies of the external validity, there is always a possibility that the test underestimate black cognitive ability, but that other disadvantages pull down black performance. If true, the validity of the test as predictors of practicable outcomes is an artificial of offsetting biases. This could explain why it is that when regressions of white performance on white test scores fail to predict black performance, they tend to predict better performance that is observed. Further, common sense notions that people from different cultural backgrounds probably have less opportunity to learn certain types of information or practice certain skills should be given some weight. If studies find that blacks do not worse than similarly scoring whites on highly culturally loaded items, that could indicate that the poor scoring whites were similarly disadvantaged. If disadvantage is more common for blacks than whites due to discrimination, that disadvantage could still explain some of the score gap. However, the strong correlation of even culturally reduced tests with performance and the similar magnitude of the gap on those tests between groups suggests that large parts of the measured gaps in ability between groups reflect real differences in average developed ability. This conclusion naturally leads to the consideration of the sources of those differences. The question of whether individual and particular group differences in cognitive ability are due more to nature or nurture has been enormously controversial for the last century. Dickens presents a summary of the evidence on the origin of black-white differences and concludes that they are most likely not sustainably genetic in origin. Rustin and Jensen reached the opposite conclusion. Whatever the right answers, asking whether the black-white gap has genetic origins is probably the wrong question. It seems that most of the reason why people are concerned with the issue is because they confuse having a genetic cause with immutability. While genes almost certainly play a large role in explaining individual differences in cognitive ability within ethnic groups raised in similar circumstances, it also seems that developed cognitive ability is highly malleable. Now coming to malleability. A large amount of evidences has accumulated on the role of genes in explaining individual differences in cognitive ability. Several reviews of this literature conclude that differences in genetic endowment explain somewhere between 60 and 80% of the variance in cognitive ability is representative samples of the adult population in developed countries. This figure is referred to as heritability of cognitive ability. It is estimated by contrasting people with different degrees of relatedness raised in the same home or people with similar relatedness raised in different homes. For example, the correlation of the cognitive ability of identical twins raised in completely independent environment will be equal to the heritability of cognitive ability under the assumptions typically employed to make such estimates. While this evidence establishes that genes play a large role in determining individual differences, little is known about which genes are involved or how the influences cognitive ability. The high heritability of cognitive ability has led some to conclude that people's environments play little role in shaping their ability and that therefore individual differences are largely immutable and that group differences must be largely due to differences in average genetic endowment. It has been argued that if all of them are correct. Coming to cognitive ability. Cognition has to do with how a person understands the world and act in it. It is the set of mental abilities or processes that are part of nearly every human action while we are awake. Cognitive abilities are brain based skills we need to carry out on any task from the simplest to most complex. They have more to do with the mechanism of how we learn, remember, problem solve and pay attention rather than with any actual knowledge. For instance, answering the telephone involves perception, decision taking, motor skill, language, social skills properly with another human being. Cognitive abilities or skills are supported by specific neuronal networks. For instance, memory skills rely mainly on parts of the temporal lobes and parts of the frontal lobes. Cognition is the mental action or process of acquiring knowledge and understanding throughout the thought, experience and the senses. It encompasses processes such as knowledge, attention, memory and working memory, judgment and evaluation, reasoning and computation, problem solving and decision making, comprehension and production of language, etc. Human cognition is conscious and unconscious, concrete or abstract as well as intuitive and conceptual. Cognitive process use existing knowledge and generate new knowledge. The process are analyzed from different perspectives within different contexts, notably in the fields of linguistics, anesthesia, neuroscience, psychiatry, psychology, education, philosophy, anthropology, biology and computer science. These are other different approaches to the analysis of cognition or synthesized in the developing field or cognitive science, a progressively autonomous academic discipline. Within psychology and philosophy, the concept of cognition is closely related to abstract concepts such as mind and intelligence. It encompasses the mental functions, mental processes and states of intelligence entities. Now coming to the tips to shape cognitive abilities. Exercise to improve cognitive function. Watch TV and read actively. Take up a new hobby. Solve all type of puzzles. Play board games and card games. Visit museum, zoos and historical sites. Become a student again. Attend workshops. For shaping behavior, a more critical knowledge resource than depth may be the individual's breadth of knowledge. Breadth of knowledge indicates an individual's cognition ability to assess the relevance, parallels, overlap and congruence of knowledge across domains, contributors who are able to recognize, access and understand different domains are more likely to make useful integrative contributions. Individuals with knowledge breadth are able to engage the perspective taking in which they receive and or share their knowledge across domains in order to identify areas of differences and similarities. Thus, organizational users are likely to exhibit their knowledge breadth by receiving or sharing their knowledge across domains either by exposing themselves to more viewpoints as they read multiple corporate or contributing to multiple wikis in other disciplines. The value of knowledge breadth to help frame conversation for improved knowledge reuse has been demonstrated in non-context. In context, an individual's knowledge breadth may foster perspective taking by providing the ability to assess the relevance, parallels, overlaps and congruence of knowledge across the different domains, thereby facilitating shaping contributions. At the same time, knowledge depth may be less important. For example, argue that individuals' knowledge depth may become a barrier when synthesis of others' knowledge is needed. Since individuals with deep expertise often have great difficulty in taking non-experts' perspectives. Therefore, we hypothesize a knowledge specifically between knowledge breadth but not depth and shaping but not adding behavior. Now coming to general mental ability, that is called as GMA. General mental ability encompasses the ability to learn and adapt with emphasis on the importance of complex information processing through problem solving, conceptual thinking and reasoning. Cognitive or mental ability is one of the most widely researched psychological constructs. The US military was the first to conduct large scale ability testing assessing almost 2 million individuals during the First World War. This testing initiated considerable interest with private sector organizations adopting cognitive testing for their business needs. As testing of GMA became more widespread, researchers began to deviate from the idea of an overarching mental ability, focusing on procedures that were intended to test multiple specific abilities, for example, mathematical, verbal and mechanical skills. As these tests could be specifically designed to include more or less of a particular ability, they were tailored to individuals' jobs according to the skills and abilities deemed important to the particular job. This tailored assessment became the dominant method for personal selection until research exploring the links between the results of ability test and employee performance revealed varying levels of validity despite the same assessment procedures being used for the same jobs. This phenomenon, labeled situational specificity, resulted in the belief that the validity of a test could not be generalized from one situation to a similar situation due to subtle differences between the two jobs. In the late 1970s, the theory of situational specificity was rebugged when advances in quantitative research techniques, primarily through the seminal work of John Hunter and Frank Sigmund, enabled researchers to determine that the differences in validity previously found were due to statistical and measurement error rather than as a result of subtle job differences. Furthermore, meta-analytic techniques enable researchers to more accurately decipher the relationship between GMA and job performance, leading to a resurgence of interest in the field. The increase in studies investigating the relationship between GMA and job performance resulted in a more in-depth exploration of the structure of intelligence, culminating in the establishment of three-stratum theory of cognitive abilities, the most widely accepted theory of GMA proposed by John B. Carroll. The three-stratum theory of cognitive abilities, not to be confused with Jacquard's stratified systems theory, organizes intellectual abilities into three distinct levels. The third level embodies a single measure of general intelligence representing GMA. The second level details 8 broad ability factors. The justification for distinguishing these broad abilities from GMA is to better explain individual differences in cognitive. By separating general mental ability into 8 distinct ability factors, Carroll illustrated why some individuals do well in particular ability tasks which incorporate one or more of the specific ability factors the individual exceeds in, but not in others which incorporate one or more of the specific ability factors the individual may lack. The first level divides the 8 broad ability factors of level 2 into more specific abilities that are more homogeneous than those of level 2. Coming to the assessment of general cognitive ability. General cognitive ability or reasoning has an important impact of everyday functioning. Reasoning skills can be impaired to a variable degree in psychotic illness. This impairment, further exacerbated by the symptoms of illness and medication side effects, may influence considerably a person's capacity to undertake normal activities. General cognitive ability was assessed in the course of survey in two ways. To assess current general cognitive ability, a test of the speed at which individuals process information was used, namely digit symbol coding test from the repeatable battery for the assessment of neuropsychological status 20. In this test, individuals fill in digits corresponding to shapes as quickly as they can on the basis of coding key. The lower the test score, the poorer a person's speed based performance. To estimate general cognitive ability prior to the onset of illness, the National Adult Reading Test revised was used. This is a test in which individuals are asked to pronounce irregularly spelt words, for example, palm. The test is based on the assumption that verbal ability remains relatively unaffected despite the decline in cognitive ability that may follow illness onset. This test is used internationally as a reliable and widely accepted measure for estimating retrospectively IQ levels in people with psychotic disorders before they become ill. Now coming to the conclusion, modern psychology views cognitive ability as having a number of dimensions, all of which seem to be correlated with one another. Many interpret this correlation as reflecting an underlying general cognitive abilities, that is measured by full scale scores on the major test of cognitive ability or IQ. General cognitive ability is an important predictor of a wide range of economic and life outcomes with similar predictive validity across groups with different average levels of ability. Still, cognitive test scores typically explain far less than half the variance in life outcomes, so cognitive ability is only one important factor among many that explain success. Adult differences in cognitive ability within representative samples of ethnic groups raised in similar circumstances are subject to sustainable genetic influence, but this does not mean the group differences are genetic in origin. Despite the large role played by genetic differences in explaining adult variances in cognitive ability, there is considerably evidence that intelligence is highly malleable and the life outcomes influenced by intelligence even more so. I hope you all enjoyed this session. Thank you, viewers.